probability. A compound event contains two or more simple events. The probability of A or B equals the probability that event A or B occurs. 170 people were asked if they smoked or not. They were listed by gender, male or female, and if they smoked or not. There were 92 males total. There were 15 females total. There were 63 males that smoked. 29 males do not smoke. 11 females smoked. 4 females did not smoke. There were 74 total smokers. There were 33 total non-smokers. The totals come from adding up either what's to the left or what's above it. What if you asked how many males or smokers there are? What happens if you add up males and smokers? If you add up the males, 92, plus the smokers, 74, this equals 92 plus 74 equals 166. But there are only 107 total people. If you add up the males plus the smokers total, you add the 63 people that are male smokers twice. The 63 male smokers got added as a male. They got added as a smoker also. The addition rule: to find the probability of A or B, you find the probability of A plus the probability of B and subtract the probability of A and B. This means add up both probabilities, probability of A plus probability of B, subtract the people that got counted twice. Add the probability that A happened plus the probability that B happened. Subtract the probability of A and B happening. What is the probability you choose a person that is a male or a smoker? Probability of A represents you choose a man. Probability of B, you choose a smoker. Probability of A and B, you choose a man that is a smoker. Both A and B, both a man and a smoker. Probability you choose a male or a smoker equals the probability you choose a male plus the probability you choose a smoker minus the probability you choose a male smoker. The probability that you choose a male is 92 males out of 107 people plus the probability you choose a smoker, 74 smokers out of 107 people, minus the probability you choose a male smoker, 63 male smokers out of 107 people. So add and subtract. Remember, when adding fractions, you must have a common denominator. Add the tops, keep the bottom the same. The common denominator won't be a problem here because in probability, the bottom is always the total. The total number of people will always stay the same. Here's a chart for the passengers on the Titanic. There were 2,223 total people, 1,692 males, 422 females, 64 boys, 45 girls, 706 total survivors, 1517 died. Men and boys are distinguished as an adult versus not adult. A person cannot be in the category man and boy at the same time. Okay, man is probably 18 and up, and boys is probably 17 and down. Women and girls are distinguished by age as well. A person cannot be a woman and a girl at the same time because woman means an adult female and girl means not an adult female. You randomly choose a passenger from the people. What's the probability you choose a man or boy? These categories do not overlap. You cannot be in both categories, so you don't have to subtract anything. The probability of man plus probability of boy, all you have to do is add those two. There's 1,692 men, 64 boys, and they're both out of the same amount of total people. What's the probability you choose a passenger and the probability you choose a woman or a boy? These categories don't overlap. You can't be a woman and a boy at the same time, so you don't have to subtract anything. So just find the two probabilities. There's 422 women plus 64 boys, They're both out of the same amount because the total number of people. 2, 2, 2, 3 total people. What about the probability you choose a man or survivor? These categories do overlap. A person can be a man and a survivor. So this probability, we're going to find the probability that you pick a man plus the probability you pick a survivor, but we have to subtract the probability of choosing a man that survived. Okay, so there's 1692 men, 706 survivors. We're going to subtract the men who survived, which is 332. And the denominator stays the same because probability means out of the total. The total stays the same, 2, 2, 2, 3 every time. What's the probability you choose a woman or survivor? These categories overlap. A person can be a woman and a survivor. The probability of woman plus probability of survivor, we're going to subtract the probability of women that survived. Okay, so women, 422 plus survivors, 706. We have to subtract the women survivors of 318 because they got counted in both categories. Another example, blood types. There are 4 basic blood types, A, B, AB, and O. Each of the 4 types can have an RH factor that's either positive or negative. So if you're type A, you're either type A positive or type A negative. You cannot be A positive and A negative. You can be type A and type A positive. There are 40 people type A, 11 B, 4 AB, and 45 O. There are 82 people that are RH positive. There are 18 that are RH negative. 100 total people. Find the probability that someone is A positive or B positive. Change to a decimal by taking the top and dividing by the bottom. You cannot be A positive and B positive, so there's nothing to subtract. So find the probability of being A positive plus the probability of being B positive, which equals 33 A positive plus 9 B positive equals 42. 42 divided by 100 is 0.42. 42 out of 100 literally means 42 hundredths, which is 0.42. Find the probability of being A or RH positive. You can be A and also RH positive. So we're going to find the probability of being A, 40 people are A, plus the probability of being RH positive, 82, minus the people that are A positive, which would be the 33. And it's out of 100 because 100 total people. Find the probability that someone is O or RH negative. You can be both. You can be O negative. So we're going to add up the people that are O, 45, plus the people that are RH negative, 18. And we're going to subtract the people that are O negative, which is 8, to give us 55 over 100 or 0.55. I'm type B negative. My kids are both AB positive. Find the probability that someone is B negative or AB positive. You cannot be both. You can't be B negative and AB positive, so there's nothing to subtract. The probability of being B negative is 2 out of 100. The probability of being AB positive is 3 out of 100 for a total of 5 over 100. Okay, here is another table on people that had cancer and if they died from cancer, and they were categorized whether they never smoked, they were former smokers, or they were current smokers. Okay, so the 125 people died from cancer. Current smoker means they were a current smoker at the time of their death. Okay, the 87 people that died means they were a former smoker at the time of their death. Okay, the table on the page just before didn't have the totals. Okay, so we have to add the totals. So add the rows and the columns to find the total. So there were 141,319, 141,319 total people. Okay, you randomly select a person. We're going to change our answers to decimals by dividing and round to 3 places. What is the probability the person died from cancer? Okay, how many people died from cancer? 964 out of the total number of people, 141,319. Okay, round to 3 places. The third place is a 6, to the right is an 8, so that 6 goes up to a 7. What's the probability the person is a current cigar smoker? Okay, how many current cigar smokers total were there? 7979. Okay, those total columns were not given. We found them by adding the rows across and then adding the columns in the total. Okay, so current cigar smokers was 7979 out of the 141,319, and we rounded it to the third place. The 6 is in the third place, a 4 beside it, so it stays. You randomly select a person. What's the probability they died and was a current smoker? Okay, so we're going to look under the died column and the current smoker row. 125 people were a current cigar smoker at the time of their death. Okay, divide by the total people. So 1 to third place value is that third 0. To the right is an 8, so that 0 goes up to a 1. Okay, here's an important note about the calculator for this part. Your calculator might say 8.8452 e minus 4. What does this mean? The E stands for exponent. This is scientific notation. So that means 8.8452 times 10 to the negative 4. The E means the exponent negative 4. When you have a negative exponent, that means to move the decimal left 4 places. So that's how we get that number. Your calculator might give it to in scientific notation. It just means move the decimal however many the exponent is. A negative exponent means a very small number. Okay, what's the probability that you pick somebody that died from cancer or was a current smoker? Okay, so the total died, 964, plus the current smokers, 7979. But we have to subtract the categories that overlapped because somebody could have been a current smoker at the time they died. So how many people were a current smoker at the time they died? 125 current smokers died. They were a current smoker at the time of their death. So we have to subtract because somebody can have been a current smoker and died from cancer. Okay, divide by the total number of people, 141,319. When we round to the third place, the 2 is in the third place. To the right of it is a 3, so that 2 stays. A complementary event means the opposite. A with a line over it means the opposite of A. If an event A is that it rains, event A with a line over it is that it does not rain. Note that P of A and P of A complement equals 1. Why do they add to 1? Probability is the decimal form of a percent. If the chance of rain is 30%, the chance of not rain is 70%, because the opposites add up to 100% the total. As a decimal, 30% is 0.30, 70% is 0.70, and 30 0.30 plus 0.70 equals 1. 1 represents the whole, which is the same thing as 100%. To find an opposite probability, all you have to do is subtract from 1, since 1 is the whole. Okay, example 1. If P of A is 0.40, then P of the opposite is 1 minus 0.40. Example 2. If P of A is 0.25, the opposite is 1 minus 0.25. Find given probabilities based on a calendar year without a leap year, so 365 days in a year. We're going to leave our answers as fractions. My birthday is December 12th. Find the probability that a person is not born on my birthday. Okay. There are 364 days that are not my birthday. 365 total, and only one of those is my birthday. So 364 days are not my birthday. So what's the probability a person does not share my birthday? 364 days are not my birthday out of 365 days. My son's birthday is on the 10th. Find the probability that a person does not have a birthday on the 10th of the month. There are 12 months in a year, so there are 12 days in a year that are the 10th of the month. For example, January 10th, February 10th, March 10th, all the way to December 10th. Okay, there's 12 months in the year, so there are 12 days in a year that are something 10. There are 365 minus 12 equals 350 days a year that are not on the 10th of the month. Okay, there are 12 days that are something 10, January 10, February 10. So 353 days are not the 10th. So 353 out of 365 days do not fall on the 10th of the month. Find the probability that a person does not have a birthday on the 31st of the month. Okay, so first we have to figure out what months have 31 days. So the months that have 31 days are January, March, May, July, August, October, and December. This is 7 months. The other months only have either 28 days or 29 days if you have leap year, or 30 days. For example, February is either 28 days or 29 days for a leap year, but we're not using leap years in this. Okay. For example, November only has 30 days. Okay, so 7 months have 31 days. There are 365 days in a year. So there are 365 minus 7 equals 350 days a year that are not the 31st. So there are 358 out of 365 days that are not the 31st of the month. That's the end.